of your data has, let's say, a specific topology, this has an impact of your model. And I mean, basically the statement you gave now that the more data you have and the more complex model you use, the better results you get, I would not sign the statement. Okay. And second, so think about that. So who does this? Who is in charge to do that? This is a strong choice, and it is dependent on the individual who does it. Okay? This is not neutral. Then the second thing is this mapping from the data to the decision space, the model, basically, again, what model is appropriate? Why should I use a neural network? Why not just to use a linear regression? Okay? And so on. So depending on the model complexity, can be very hard to interpret the model results and so on. What metric do I use to measure the quality of the models and so on? And the metric you use to basically to measure the quality of the model sometimes has nothing to do with the metric you should apply based on the decisions which are taken based on the model output. Okay? And the last is basically that, yes, if you have the decision space, so if you have your result, then yeah, what actions do you do based on this result? Okay? So what I want to show you here is that the whole chain to build a model is prone to biases. Biases, let's say, or unfairness, you can induce. Okay? And there is no standard how you can avoid it. There is no way of a procedure you can follow that this doesn't happen. Okay? And this shows already that the problem is much more complex than to inspect a confusion matrix from a model. Okay? It goes far, far, far beyond that.
So what did you say? How do you define bias?
I will come there, but you have an intuitive feeling what it means. It can be that, for example, you are unfair against the subpopulation, for example. That's a good description of it.
That's very dependent on the use case or on the domain that we're looking at. What is kind of unfair and
yes,
bias.
exactly.
And are we not, maybe that's called later, but when we try to remove the bias or the unfairness, are we not like introducing just another form of bias?
Yes, this is exactly what I said before. Okay. So this is like a dilemma. So you have a good, let's say your model is very nice, there's a high quality, but you know that it's unfair somehow. Is it okay just to leave it this unfairness? Okay? But then you have the danger that if you basically take this model and put it somewhere else, you do something which is not good. Okay? So what I want to show here is really that it's not that simple that you inspect a single metric of something. So you have to think about the whole chain, and there are a lot of mistakes you can do. Yeah.
But I was wondering, coming back to the example of the hiring process. So, how would you know that the model is unfair?
We come to that. I mean, you can measure it, okay? But there
you can measure it if you already know the unbiased reality, right? Like, for example, like I would know that the model is unfair if I know that women and men are too alike, which is an hypothesis that I make already. Maybe this is a bias, maybe this is true. And then if my model gives more possibilities to be hired by men, then it's pretty obvious that this is unfair. But this is based on an assumption that I have at the beginning.
Yes, I mean, what you can do, I mean, there are, let's say, bias you can connect to societal values. Okay? Yeah. Like, it makes no sense to have a model which prefers only male, or only, for example, okay? Or it makes no sense to have a model which prefers only white-collared people. Makes no sense. Yeah. So, and if you think about that, then it is pretty clear what bias means. Right? So, what
it's like more justice and moral justice
like,
of the model.
Yeah.
Okay. Yeah. Okay.
So basically we come to the point how we might get. So I really want to go top down.
Yeah, I don't want to spoil the party here, but what about if your domain, per se, is driven by the wisdom of crowds?
yeah, what you mean by wisdom of crowd? Sometimes it's not the wisdom, but it's the dumbness of crowd. I mean, this basically really is depending on the question you ask to the crowd. Okay, so if basically, I mean, I can ask the crowd about the Schrödinger equation, something which makes no sense, right? But I can ask the crowd to basically try to guess what is the weight of that. Something like that. The crowd is very.
That's real binary questions in a way. But when you have a domain which is driven by rational exuberance, that might last for a period of time. That period of time I perceive to be reality.
Sorry, I didn't get it. What exactly
The
is the
wisdom of
question?
crowd sometimes leads the environment to an irrational exuberance. Like we follow, like let's say stock market, might go for 2 or 3 years one way when reality and logic dictates the other way. So it's driven by rational behavior. Running a model in that instance, if you are retrospectively trained with the past,
yes.
the past is driven by rational
yes.
behavior, so by default is biased.
Sorry, you say that past is driven by rational behavior.
Irrational behavior.
Yes, exactly. But I mean, if you, let's say, if you're looking for data, you need to do something. Yeah, you have, of course, you have this kind of characteristics in the data. So that's exactly what. I mean, if I look at the comments people write, they are quite unfair. Okay, so it makes no sense sometimes what they write, but basically it makes no sense to neglect this reality and make the model fair because the model does not work in that way. Okay. So I don't know if I could answer the question with the wisdom of the crowd. So I'm not a strong believer in this concept, honestly. So okay, so basically when we think about bias or fairness in algorithms, then we should really think about the whole chain and not only about the models, because this is what people do. So people really, they think about just the model. Okay, so but now let's because we cannot cover everything, but let's say we think about a bit more precisely about models. What we have basically is that, and as I said that in many words before, that the model basically is challenged by the environment, the data, and the objectives you put on the model to let's say, to measure the goodness or the quality of the model. So then what is a good model? Let's come right through to the thing we want to do. A good model probably is a model where you can have as well some causality. I know it's something difficult because basically all machine learning approaches, they do not take into account any causality, right? So what you have there are correlations, spurious correlations sometimes, but not causality. But probably we should try to do it. And if you look a bit in the research literature, then you see that people now, they really try hard to introduce as well causality. The problem here is that you have to take some strong assumptions, and probably they are biased as well. Then, yeah, we want to have a model which is transferable, at least within the same dynamical domain. But then, of course, we want to have a model which is fair, and let's say a model is fair or ethical, somehow correct, when it fulfills these points here. So, and what I want to do now is basically we zoom in one of these points, namely transparency. So transparency means that you have basically a description and explanation of decision-making algorithms mechanics. So that means that you really understand what the model is doing. Do we understand what a neural network is doing? No, not at all. People don't understand it. Okay? Nobody understands it. Yes, nobody. We know what is the objective. We give the objective. It's a mathematical function. We optimize. That's it. But we have no clue basically, we have no model, we have no meta model which can describe how basically the neural networks get to his result. So we have these 23 million parameters, okay, and they adjust somehow, but there is no theory why it adjusts it in that exactly that way. Okay, yeah.
If it is reproducible and understandable by humans, doesn't that kind of restrict the whole thing as well? It could be better than us.
Yes, I mean the point here is what is understandable. I mean we come to that point. I mean you can have this kind of post hoc exploration what a model is doing and try to explain what it's doing, but that doesn't mean that you really understand the inner mechanics of the model. These are two different things. Okay, I will explain that right now. So if you want to tackle this challenge of ethics, because now you read a lot of ethics and machine learning, at least you have to solve the problems in all these buckets here. So, but we cannot basically do everything. So that's why I will a bit zoom into this transparency bucket. So what we need here is a definition of bias or of fairness. And how it's related to transparency, and what we need is, are some concepts, let's say, that tell us what we can say about transparency, how we can say something about transparency. And one class, basically, this class is the most explored at the moment, are so-called post hoc explanations. So that is the following: you have an outcome of a model, okay, like. It should detect cats or dogs on an image. You have an outcome of a model, and then the model tells you this is a cat with 84% probability, for example. How can you explain this decision of the model? So one way is that you try to figure out what are, for example, the relevant features of that image that the model did that for that decision. Okay, so basically you have a trained model, and then you go back and try to explain by various techniques how the model got this decision you have as an output. Okay, this is called post hoc, and it's at the moment the one which basically is explored the most. For example, if you have probably you have seen it already once. You have these object detection systems, and then they generate a kind of an explanation with a text. I decided this must be a cat because I see this, and this in the image, for example. Or you have these salient maps, okay, where you can see where the neural network, where it focuses on the image. So this is a kind of an explanation why the model did this and this. Okay? But it doesn't tell you anything about what is the inner working, why the model gets these weights it got at the end of the training. Okay? This is different. So this is basically a mechanical explanation, and the research there is still in its infancy. Okay? So neural networks are not really understood yet in that perspective. So one thing you can try is, and what people do, is a small community, but they try to understand these neural networks in a more physical way. So they try to map basically what happens, because what happens in a neural network, right? So you have an affine transformation followed by a nonlinear calculation, and that's it. Okay. So for each unit you have, and then you give basically you give the output of a unit to the next unit in the next layer. So this is what happens. And basically what people try to do in that bucket here is they try to map this kind of dynamics to a known physical model, like for example spin models. Okay, and when you succeed in doing that, what you have is you have the chance, because spin models are understood in physics. You can make predictions. Okay, based on an initial condition, you can make a precise prediction what will happen in the model. And you cannot do this with neural networks. Okay? You have to push the data through the network to see what happens. You cannot say upfront what will be the score for that image. No way to do that. Yeah.
Maybe a bit of a off-running question, but why is this actually important? I mean, talking to the psychologists, we don't probably even fully understand how we make this.
Yes. Yes.
So
yes.
Isn't this like a high goal to understand how the models
yes.
make this decision?
The point is, if basically, that's why here in the post hoc it is written similar to humans' explanation why a specific decision has been taken. So if you decide something, I can go to you and I can ask you, why did you decide like that? And you give me an explanation. Okay?
What feeling, experience?
Whatever. But this explanation is mostly entangled from the real process, what happens in your brain. Okay? That's why this kind of post hoc thing here is something similar to what we would expect to get an explanation for a decision. But the thing is, it would be very nice, you know, it would be very powerful when you can say upfront, before you feed data to a system, what basically is, to a certain confidence, what will be the output. Because if you can do that, you can upfront basically explore what is the limit of the system, where does it not work anymore, okay? Because just by exploration, post hoc, you find some specific example where it doesn't work. Probably you can figure out some patterns, but you will never ever cover all the patterns. But when you have a kind of a meta theory which tells you what will happen, okay, that's much more powerful. And this is a small community, mainly physicists work on that, and nobody cares, of course. No, but but it's really it's worth to go that path as well. And then the third one is I call it data-based explanation. So you basically explore the data before you start to train something. Okay? Of course, you can detect, for example, that you have in your data subpopulations which are much less, where individuals are much less frequent compared to other. And if you know that, let's say if you have only 10% women in your data and on 90% men, and then you feed the data for training, then you know basically at the end how you have to handle that, right? So you can basically inspect upfront the data and then see if you basically potentially will generate a bias in the model. And this, I think, is also what IBM more or less does. So they inspect the data and try to figure out with some statistical, so with descriptive statistics, if something like that then can happen, or where we should focus. Okay, now we talked a lot about fairness and bias. So what do we mean by fairness and bias?